Welcome you all dear students. So this is the lecture number 2 on the Mayer theory, and obviously we are talking about the chapter number 1, the Lebesgue Mayer. So I, Dr. Bharat Goyal, welcome you all to my channel, and the notes are prepared from the book Real Analysis written by H.L. Royden from the 4th edition. So in the previous lecture we have talked about the basic goals of the chapter, out of which the first goal of the first stage will be the definition of the Lebesgue outer Mayer and to study its properties. So firstly, what is an outer Mayer? The outer Mayer of the set A of real numbers to be defined as infimum of the sum of the lengths of the intervals i's which are non-empty, open, bounded, that covers A. So what is the logic behind it? We have to find those intervals which covers the set A. For example, if I have taken the set 1, 2, 3, 4, 5 simply, then we have to find some open, bounded and non-empty intervals that cover this collection. For example, we can consider an interval from 0 to 0.5 to cover 0 to 1.5 to cover the point 1, and then the interval 1.8 to 2.2 to cover the point 2, and similarly for to cover 3 we can construct 2.8 to 3.3, and somehow to 4 similarly for 3.8 to 4.2, and to cover 5 we can create an interval for example 4.9 to 5.3. So we need some intervals to cover the elements of the set. Then what we have to do, we have to calculate the length of all these intervals, and then we have to take the sum of these lengths. And obviously because the intervals that I have find out are not unique, so they are somehow very much in number, so we have to consider that collection whose sum will be the least infimum. Obviously I am taking a example from the real life. For example, if I want you to cover a room with the newspapers, so what you have to do, you will paste the newspapers on the walls, and obviously somehow first student suppose covers the room with the 100 newspapers, and but the other student cover the same room with the 50 newspapers. So that means the first student has somehow make the room the newspapers overlapping newspapers, because he has used 100 newspapers, but the same room is managed by also by the 50 newspapers. And it is also possible that the second student has managed it by 50 newspapers, the third student may manage to cover it by only 30 newspapers. So obviously we will recommend the third student who has covered the room with 30 newspapers. And suppose if 30 is the minimum number, because if we decrease single newspaper from 30, then the room will remain somehow uncovered from some portion, so that will be a problem. So 30 is the minimum number, and obviously you will prefer the student number 3 who has used the less number of newspapers. So similarly we have here the outer Mayer definition, that infimum, that means we have to take the greatest lower bound. Here we are not writing minimum because the collection will be infinite, the intervals may be infinite in number. So if we are taking infinite in number, then we can't find the minimum. Yes, we can find the greatest lower bound, and we have to find the greatest lower bound of the summation of the length of the intervals which can cover the set A. So this is the definition of the outer Mayer. So it is clear from the definition of outer Mayer that the outer Mayer of the phi will be 0, obviously, because phi is a empty set and we don't need any interval to cover the phi. So obviously its outer Mayer will be 0. So thank you very much.